Nuclear Chemistry, Part 7, Ionizing Radiation. In this video, we're going to compare and contrast the major sources of ionizing radiation. First, why don't you stop and consider this? You're exposed to ionizing radiation every day. Where do you think the majority of your exposure to ionizing radiation comes from? Do you think it comes from nuclear weapons testing fallout? From the sun? From your mobile electronic devices? Or does it come from somewhere else? Do you have your answer? Good. Let's find out. Before we look at ionizing radiation, let's look at non-ionizing radiation. Non-ionizing radiation is non-ionizing because it's low energy. It doesn't have enough energy to strip electrons from atoms and molecules, so it cannot damage your cells. Most radiation is this non-ionizing form and is completely harmless in everyday situations. Non-ionizing radiation includes things like radio waves, used for Wi-Fi and cellular signals, and microwaves, used for, microwaves, and for satellite communications, infrared radiation, which you typically can feel as heat, and visible light, the only radiation your eye can see. That's why we call it visible light, all the colors of the rainbow. These are all non-ionizing radiation, and don't really have anything to do with nuclear radiation at all. Ionizing radiation includes the ultraviolet, the X-rays, and the gamma rays from the electromagnetic spectrum. All nuclear radiation is ionizing radiation, be it from alpha, beta, or gamma sources. Ionizing radiation has sufficient energy to knock electrons loose from the atoms and molecules that it interacts with. This can damage cells, primarily by mutating the DNA and causing the cell to malfunction or to die. This is the kind of radiation people usually think of when they talk about the dangers of radiation. Nuclear radiation isn't something that you can detect with your senses. Radioisotopes do not look or smell or feel any different from non-radioactive isotopes. In fact, if you recall, all the chemistry for different isotopes of the same element, radioactive or not, is the same. There are instruments that detect radiation, and two of the most common ones are shown here. A Geiger counter has a tube filled with a gas that becomes charged when ionized by ionizing radiation. The charge is detected by the circuitry, and it makes a beep or a click or moves the needle to show you how much ionizing radiation is being detected. Another means of detecting ionizing radiation, through a film badge, works similarly to the way Henri Becquerel accidentally discovered radioactivity. The piece of film is sealed in a container that you can wear around if you work with ionizing radiation, like with X-rays or nuclear medicine, for example. And then someone can take the film every so often and see how much it's been exposed to ionizing radiation. If it is much more than it's supposed to be, then your boss may have to give you a few extra days off of work or reassign you to a different department so your body can repair any damage from the extra exposure. Regular folk don't need to worry about wearing these film badges around, but everyone is exposed to ionizing radiation every day. The normal, regular, average exposure to ionizing radiation is known as background ionizing radiation, and most people in the same part of the world experience about the same levels. The vast majority of it, about 82%, is from natural sources of radiation, from space, from the ground, from the atmosphere, and the environment you live in. You can see here that the majority of your typical exposure, about 55%, is from radon-222, which is found naturally in the air you're breathing right now. Your body is made of atoms, and some of those atoms are radioactive isotopes, like carbon-14, potassium-40, and iodine-131. So you have yourself to blame for about 11% of the ionizing radiation you're regularly exposed to. You're also exposed to some ionizing radiation from space, and some from underground where things like uranium-238 and thorium-232 decay in the rocks and in the soil. This is all normal background radiation from natural sources. Since humans came on the scene, we've added some synthetic sources of background ionizing radiation. Still pretty low in the grand scheme of things, so nothing to be concerned with. There's a big chunk from the medical X-rays that you'll be exposed to throughout your lifetime and from nuclear medicine for various scans that doctors sometimes prescribe. And a small portion from other man-made sources, like when we burn fossil fuels or fly in an airplane, or from the materials and products we buy, build our houses out of, and eat. All of the synthetic sources add up to about 18% of your background ionizing radiation, And because you're exposed to it gradually over the course of a year or a lifetime, and not all at once, it doesn't really make an impact on your cells or your health because your body's immune system can repair any damage before it becomes a problem. Fortunately, you don't really spend your time hanging out with a bunch of radioactive waste. I don't know, maybe you do, I don't know all your friends. But radioactive waste is something that we as a society have to deal with. But let's see what you think about this first. Which of the following sectors do you think produces the overwhelming majority of the radioactive nuclear waste produced in our country every year? Do you think it's hospitals, with all the nuclear medicine they do in their radiology departments? Or do you think it's the energy sector, because of the percentage of the energy that's produced is from nuclear power plants? Or do you think it's education, from all the nuclear research labs at various institutions around the country? Or is it the Defense Department, from nuclear weapons use and testing over the past century? Where does most of the radioactive nuclear waste come from? It's definitely from hospitals. About 80% of the radioactive waste produced in a year comes from hospitals due to all the radioisotopes used in the diagnosis and treatment of disease. Only about 20% of our radioactive waste is produced from nuclear power reactors to generate electricity. The hospital's waste is considered low-level waste because it primarily has short half-lives. So after a while, if you store it locally, it will decay to a low enough level that it isn't really considered radioactive anymore. For nuclear reactors, the radioactive waste products are a much bigger hassle to deal with, and it's considered high-level waste. Some of the isotopes have such long half-lives that it's essentially from now until forever that it's going to be radioactive. The current solution to this problem is to store the waste on site at the nuclear power plant until we can come up with some sort of long-term solution. There are several potential long-term storage solutions, but they're all pretty expensive, so most energy companies just bury it in concrete at their facilities and hope they don't run out of space anytime soon, because it isn't going anywhere. So, what have you learned? Where is most of your ionizing radiation exposure coming from? From the air. It's coming from the air you breathe. Recall that just over half of the ionizing radiation you're exposed to is from radioactive radon gas naturally found in the air you breathe. If you want to live a radiation-free lifestyle, then you're going to have to stop breathing, and I wouldn't recommend that, unless you're underwater. I hope you're not underwater right now. Leave a comment if you are underwater right now, because that's got to be a good story. I hope you've enjoyed looking at the major sources of ionizing radiation that you're typically exposed to. Now, have a wonderful day.